So this will be the fourth lecture out of chapter 1. So in this lecture, we'll talk about this concept of dimensional analysis. So dimensional analysis is just a method to set up a problem, do the calculations, and keep track of your units while you do the calculations. So we'll work a few examples just to illustrate the concept. So basically, we're going to set up a calculation in a grid like this. And basically, you're just going to end up multiplying the tops and then multiplying the bottom numbers. And then you're going to divide the two numbers by each other. And you'll get an answer. So it's a good way to keep track of units, because if you end up with the right units when you do the calculations, say you're trying to calculate distance and you end up in meters, you end up in the right units, a unit of distance, then you probably did the calculation right. And if you do the calculation and you end up with the units that are not right, then pretty good chance you did the calculation wrong and you need to go back and change something, figure out what you did wrong in the calculation. So basically in this class, I don't care how you solve problems, you can set them up on a dimensional analysis like I'm fixing to do. But I don't really care how you solve a problem so long as you show the steps, how you solve the problem, keep track of units in your calculation, and arrive at the correct answer. That's all that matters to me. So you don't have to solve problems the way that I solve problems. But you do have to show me how you solved a problem if it's something that you had to submit, for example, to be graded. Okay, so to illustrate this concept of dimensional analysis, I'll just take a few examples from my own personal life. So I've drove to Alaska three times, I think it is. I either drove to Alaska or drove from Alaska back to Texas. And the first trip that I did this was very educational for me because you had to go through Canada. And when you drive through Canada, well, Canada uses the metric system. So it's no longer miles per hour. Now it's it's kilometers per hour. It's no longer how many miles to the next town. It's how many kilometers to the next town. So we'll work a few examples to illustrate this concept. But I was very appreciative that I was a scientist when I drove through Canada because I knew the metric system and I knew how to do conversions. So the next town was 500 kilometers ahead. I knew how to do the math and figure out how many miles that is because I don't think in kilometers, I think in terms of miles, right? I don't think in terms of kilometers per hour for speed, I think in terms of miles per hour. But fortunately, most cars have miles per hour on their speedometer and have kilometers per hour as well. So that's not such a big deal nowadays. But if you're wanting to know how far something away it is and it's in kilometers and you don't know how to do the math, then you're clueless, right? How far that is. Okay, so anyway, while I was driving through Canada, the cheapest gas that I found, so I was driving along the road and I saw the marquee saying how much the gas cost, and I saw 135 and my mouth hit the floor. It's like, whoa, no way this gas is $135 dollars per gallon. I knew Canada was expensive, but that would be outrageous. So it took me a few seconds, but then I realized, okay, I'm in Canada. This is the metric system. This is probably not dollars per gallon. So what is it? Well, what it is cents per liter. So this gas happened to cost 135 cents per liter. And of course, that didn't make much sense to me because I don't think in terms of cents per liter. So I don't know if that's expensive or if that's cheap. I knew it was going to be more expensive than the United States because gas is higher priced in Canada. But I still didn't have a real good concept of how that is. But fortunately, I had a phone, and so I could do calculations, but I did not know the conversion factors. I did not think about this before I left the house. And this was a few years ago, so you didn't have all of these phone plans where you could just turn on roaming while you're turn on, or you couldn't just log into your AT&T account or whatever, for example, and add international travel to your plan and then turn it back off when you got home. It didn't work like that a few years ago. So I was going through Canada without Wi-Fi. But I did know if I drove into a McDonald's, they would have free Wi-Fi. So that's just what I was doing all the time, as I was finding places to pull over that had Wi-Fi so I could get free Wi-Fi. And then I could Google search how many my conversion factors. So if you want to do this calculation, you need to know some conversion factors, right? You need to know how many liters are in a gallon. So if we want to convert cents per liter to dollars per gallon, so that's one of the conversion factors you need, and you need another conversion factor, right? And of course I knew this conversion factor. This one's easy. I knew that $1 is equal to 100 cents. So if you know those two conversion factors, then you can do this math, right? So let's set this math up in a dimensional analysis problem. So let's convert cents to dollars and liters to gallons. So since cents are on top here, then we need cents on the bottom here. And we need dollars on the top, because we want dollars to be on the top of the N, right? Because we want dollars per gallon. Or per means the next thing is on the bottom. So per gallon means gallon is going to be on the bottom. So we need cents on the bottom and we need dollar on the top, so the number stays with the unit, so we need the 100 cents here and we need the $1 there. So now when you do the math, cents are going to cancel out, and now if you just did those, so that would be $1.35 per liter is what that gas costs, right? Because now your units is dollars per liter. So another conversion factor, now we need to convert liters to gallons. So since liters is on the bottom here, then we need liter to be on the top here. And then we need gallon then to be on the bottom. And so this number has to stay with the liter. So we would have 3.785411784. So I like to be very as accurate as possible in my numbers. So I would be doing this calculation in the parking lot, keeping all of these decimal points in my calculation. So 3.78541178 liters is the same thing as 1 gallon. And so now, let's see, liters are going to cancel out, and the only units left is dollars on top and gallons on bottom, so you know you're in the right unit, dollars per gallon. So multiply the tops, and then multiply the bottoms, and then divide those two numbers by each other, and what you should get is $5.11, or $5.11 per 1 gallon. So that gas cost $5.11 per gallon, and that was the cheapest gas that I found while driving through Canada. This was several years ago. Gas was pretty expensive in the United States at that time as well, as up to maybe $3 or almost $4 a gallon. So, but that was still pretty expensive. So, but the most expensive gas that I came across that I bought was 185 cents per liter. But I didn't have much choice because there weren't many gas stations around and I was getting low on gas, so you got to pay what you got to pay, right? So how much is this gas cost? So now if we change this to 185 cents per liter, so $1 is 100 cents, and 3.785411784 liters per 1 gallon. And if you do that math, multiply the tops, multiply the bottoms, and then divide the two numbers, you get $7 per gallon. So that was really expensive gas. I was not happy about paying $7 a gallon for gas, but there was no other gas around, and you do what you got to do. Okay, so this is not the end of the story, because then when I looked at my bank statement and I tried to balance my checkbook, I recognized that, let's say I spent $36.25 filling up my gas tank, for example, and I looked at my bank statement and there was no charge for $36.25 on the bank statement. Why not? Is because I had forgot about another conversion. I was in Canada. I was thinking in terms of American dollars, US dollars, but this is Canadian dollars. So if you want to do this conversion, then you have to know what the exchange rate is, right? So at the time, the exchange rate, $1 Canadian dollar was 0.919517 US dollars. So if we do that conversion, 36.25 Canadian dollars is the same thing as 0.919517 US dollars over 1 Canadian dollar. So that's your conversion factor. And if you do this math, then that works out to be 33.33 US dollars is what that tank of gas actually cost to me. So because the exchange rate was favorable towards the US dollar compared to the Canadian dollar, so that's what would have been on my bank statement, right? So anyway, so this trip, basically what we did is come up through Montana, through Alberta. That's just where the cheapest gas was at. And then through Alberta, British Columbia, and then up onto the Yukon, and then into Alaska. And this is where the most expensive gas was at. Right, so why is it most expensive in Yukon? Because it's a long ways away from anything. There is nothing out there, right? So you can drive a long ways and not come across many gas stations. So if gas is $7 a gallon, that's what you're going to pay. Or you're going to be stranded along the side of the road. And the cheapest gas is in Alberta, which was not surprising after I thought about it a while, because Alberta has a lot of oil and gas industry there. And plus, it's the closest to the U.S. border as well, so easiest to ship gas to there compared to the Yukon. So anyway, if you like the outdoors, then I highly recommend that you add this trip to your bucket list. And you know, it's nice to fly and get places fast, but it's also nice to drive as well, because you get to see everything in between. And it's an absolutely stunning drive. Drive through the Rocky Mountains, so it's very beautiful. Tons of wildlife. Saw lots of black bears, lots of grizzly bears. I think on one trip we saw almost 30 black bears on one side of the road. Drove through an entire herd of buffalo in British Columbia. Saw wolves, saw eagles, saw moose, all kinds of wildlife, mountain goats. So very fun trip. But it takes a long time. It's about 4,000 miles. So it took me a solid week of driving, 7 days. When I drove it by myself, I was driving about 12 to 15 hours a day, and it took me an entire week to get there. On the drive back with kids, we didn't drive 12 to 15 hours a day. We would drive about 8 hours a day and then pull over and camp somewhere. Okay, so let's work a couple more problems. So you're low on gas. The next town is 259 kilometers ahead. That's what the road sign says. So how many miles is that? So again, if you want to do that you need a conversion factor, right? So 1 kilometer is 0.6214 miles. So since kilometers is on top here, then we need kilometers on bottom here, and then 0.6214 miles on top. So if you do that conversion, that is 160.9 miles. So that town's 160.9 miles ahead. So I was doing this calculation all the time. I know you're not supposed to be on your phone when you're driving, but I wanted to know how far that next town was, so I was doing this conversion factor on my calculator all the time while I was driving. Okay, so if your car gets 23 miles per gallon, how many gallons do you need to drive that 259 kilometers? So we just need another conversion factor, and that's your conversion factor. It's 23 miles per gallon. So if you're having to drive 160.9 miles, and so miles needs to be on the bottom, so the 23 has to stay with the miles. So 23 miles goes on bottom, and 1 gallon of gas. So your car goes 23 miles on 1 gallon. And now if you do this, so multiply 160.9 times 1 and divide that by 23, and you get 7 gallons of gas. So your car is going to burn 7 gallons of gas on that drive. Okay, so of course there are many ways to solve this problem. You don't have to use dimensional analysis. You could do the calculation like this: 259 kilometers divided by 1 kilometer per 0.6214 miles. And of course, if a unit is on the bottom of the bottom, that's the same as it being on the top, right? And if you're dividing a number, the bottom of the bottom is the same as multiplying by that number. So basically you're doing the exact same math as here. And the same thing here, if you had to go 160.93 miles, you could divide that by 23 miles per gallon, and then miles cancel out. Gallons is on the bottom of the bottom, which is the same thing as being on the top, right? So that would give you 6.997 gallons, or rounded to 7 gallons. And so when I did this calculations, I did not keep track of significant figures. So usually I'm not that picky about you keeping track of significant figures. If the question specifically asked for you to keep track of significant figures, then obviously I care. But for the most part, I'm not that picky. With your math, I just want to see that you set the problem up correctly, but you should know how to keep track of significant figures. So if we were doing that for this problem, it would be ambiguous because I give you this number and it doesn't have a decimal point. So and this number didn't have a decimal point, so it's kind of sloppy. So if I wanted you to keep track of significant figures, then maybe I would say 259.0 kilometers. Now you know there's 4 significant figures, right? And you would have to, and if I gave you this 23.0 miles per gallon, then now I'm giving you significant figures, so now you can keep track of significant figures in your calculation. Okay, so another thing that this chapter covers is the different temperature scales. So you should know how to convert between Fahrenheit, centigrade. So those would be the 2 temperature scales you're no doubt familiar with, but there's another one in chemistry called the Kelvin scale that you want to know as well. So if you're given Celsius, it's easy to convert to Kelvin. Basically, you take whatever temperature you're given in Celsius, multiply it by 1 Kelvin over 1 Celsius. What's the purpose of doing that calculation? Because you're just going to get the same number, right? Well, the purpose of doing that, so if we take an example, so if you have 100 degrees Celsius, what is the temperature in Kelvin? Well, 100 Celsius times 1 Kelvin over 1 Celsius, the purpose of that is to cancel out the Celsius to convert the units. And basically all you do then is add 273.15. Whatever Celsius you have, add 273.15, that's your temperature in Kelvin. So this would be 373.15 Kelvin. 100 Celsius is 373.15 Kelvin. For our purposes, you don't have to worry about the 0.15 really. 373 would be sufficient. We can forget about the 0.15, but if you want to be as accurate in your calculation as possible, then you would include the 0.15. So Celsius to Kelvin, just add 273, right? Or if you're going from Kelvin to Celsius, subtract 273. Okay, so if you're given Fahrenheit, or if you're given Celsius, so this is to convert from Celsius to Fahrenheit, then this is your equation. Take whatever temperature in Celsius you're given, multiply it by 9/5, and then add 32. So if you had 100 degrees Celsius, for example, if we want to convert that to Fahrenheit, so 100 degrees Celsius times 9 degrees Fahrenheit divided by 5 degrees Celsius. So Celsius is going to cancel. Now you're in units of Fahrenheit, and then add 32 Fahrenheit. So this would be, well, 100 degrees Celsius is the boiling point of water. In Fahrenheit, that's 212, right? But let's just do the math to make sure. So 100 times 9 divided by 5, that gives you 180, plus 32 gives you 212 degrees Fahrenheit, right? Or if you're given Fahrenheit, so this equation, if you're given Fahrenheit and you want to convert it to Celsius, this is your equation. So take the temperature in Fahrenheit, subtract 32, and then multiply it by 5/9. So if it's 98 degrees Fahrenheit, for example, what is that in Celsius? So 5 degrees Celsius over 9 degrees Fahrenheit, and then take 98 degrees Fahrenheit minus 32 degrees Fahrenheit and calculate it out. So 98 minus 32 is 66, times 5 is 330, divided by 9 is 36.7 degrees Fahrenheit, right? Okay, so lastly, so the Kelvin scale is what's called an absolute temperature scale. So an absolute scale starts at an absolute minimum. In this case, 0 Kelvin is absolute the lowest temperature you can go. So it starts at 0 and then it progresses in one direction. And so this basically means there is no negative Kelvins. It starts from 0 Kelvin and goes positive. So absolute 0 Kelvin is the lowest temperature you can possibly go. And in theory, at that temperature, all molecular motion stops. So a relative temperature scale, such as Fahrenheit or Celsius, begins at an arbitrary point. selected by a person or an organization and progresses in both directions. So the Celsius scale has its 0 point at the freezing point of pure water, so 0 degrees Celsius, right? And then you could either go negative Celsius or positive Celsius. So Fahrenheit also has an arbitrary 0 point. So 0 Fahrenheit is basically the freezing point of brine. A brine solution is a very concentrated salt solution of water. So a change in 1 degree Celsius is equal in magnitude to a change in 1 Kelvin, but this is not equal in magnitude to a 1 degree change in Fahrenheit. So the Celsius and Kelvin scales are linear with respect to each other, but they're not linear with respect to the Fahrenheit scale. So that's an example. So if you have 0 Celsius, that's 273 Kelvin, right? If you have 1 Celsius, that's 274.15 Kelvin. So you change the temperature by 1 degree Celsius, and it also changed by 1 Kelvin. But if we did this for Fahrenheit, Celsius versus Fahrenheit, so 0 Celsius is 32 Fahrenheit. If we go to 1 Celsius and change that to Fahrenheit, so if we plug in 1 degree Celsius here and calculate the Fahrenheit, that's 33.8 degree Fahrenheit. So that changed, so the change was 1 degree Celsius, but it was 1.8 degree Fahrenheit, right? And then if we go to 2 degrees Celsius, so if we plug in 2 degrees Celsius here, times 9 divided by 5 plus 32, you would get, sorry, this should be Fahrenheit. You get 35.6 degree Fahrenheit. So again, the change is 1 degree Celsius, but it's 1.8 degrees Fahrenheit, not Celsius. Or if it's 10 degrees Celsius, that's 50 degrees Fahrenheit. 283 Kelvin. So we changed the temperature from 0 to 10, so 10 degrees Celsius changed by 10 Kelvin, but it changed by 18 degrees Fahrenheit, so they're not linear with respect to each other. But main thing that you'll have to do is just know how to convert between the different temperature scales. So there is another temperature scale. I know a lot of the students in this class are engineering majors. Engineering majors often use what's called the Rankine scale. We're not going to talk about that, but engineers will probably see that at some point in their studies. Okay, so hopefully that made sense. That's basically how you do dimensional analysis. Again, you don't have to solve problems using dimensional analysis, but it is a nice method because it's a really easy method to keep track of units, and if your units work out when you do the math, you probably got the right answer. And if your units did not work out, you probably got the wrong answer, and you have a mistake that you need to fix. Okay, we will stop there.